Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture we will discuss the conditions of equilibrium for a submerged body. In our previous lectures we have discussed the condition of equilibrium for a floating body. So let's discuss the concept of these conditions of equilibrium for a submerged body. So floating body we have seen, that means the body is going to float over a liquid. Now here the body is going to submerge inside the liquid. Okay, so let consider some conditions are there. Again, for these conditions of equilibrium will be, as I told you previously also, same here also will be there. One is stable equilibrium and one is unstable equilibrium. Another one is neutral equilibrium is there. So these are the three different types of equilibriums. This is stable equilibrium, and this is unstable, and this is neutral equilibrium. So three different conditions are there. So first we'll discuss the stable equilibrium. Okay, so stable equilibrium, let me consider a small balloon here. Okay, and which is filled of some heavier materials inside the balloon. So the balloon structure will be like, it will be like this. Yeah, and this balloon structure will be like this only, but inside this one, okay, let me erase it again, let it draw. Okay, yes, and this bottom part of this, okay, let's fill it some heavier materials to this one. Okay, like this. Now you can ask one thing, sir, when it is submerged in the liquid, because no liquid you have considered here. So here you can consider this one. This is suppose chamber is there, and this is filled of full fluid is there. Inside this fluid, this balloon is situated. This fluid is nothing but air will be there. Okay, a balloon is there which is submerged in a air. Okay, that is also one fluid. Now in this balloon, if you see, and here just what we have kept, some heavier materials we kept on the bottom of this part, so that the balloon will be structured like this. And if the balloon will be here like this, then we know that the axis line of this balloon will be here in this way, and the weight of this total balloon is going to act at this point, so that is nothing but our center of gravity point. Okay, where the total weight of the body is exists. So that is your G point, center of gravity point here. Okay, but your center of buoyancy point will be different. Okay, center of buoyancy point will be how much submerged is there in this body total, based on that the point of force of buoyancy acting at that point. So this is our B point will be there. For this condition actually it will be reversed. The B point and G point both will be reversed, because the more weight we have given at this bottom side. Due to that, the G point is changed its position. So what is G point? Already told you previously. G is the center of gravity of the body, CG of the body, and B is the nothing but the center of buoyancy, the center of buoyancy of the body. Okay, now when we can identify whether this balloon is stable condition or unstable condition, let do one thing. Let rotate this object. Okay, few rotation, let do it, and so that after rotation, what will get the structure of this balloon will be not like this. Yeah, again let's draw it. Okay, it will be like this only somehow. Yeah, and again after rotation you can see, so this will be our axis line, because it was rotated in this way. Now after rotation, if you see, yeah, so this is the axis line of this, and now if you see, this is the total filled material, heavy material is there here. Now due to this rotation, again your G point will be here only. Your G point is there, and the B point, which is above to this G1, which is at this center point of this. So this is B. So we know that at the B point the force of buoyancy is going to act, and the G point we know that weight of the body is going to exist. So by this law we can say, so the W is going to act on this vertically downward, and the force of buoyancy which is acting at this B point, that is going to upward, vertically upward direction. And we know that the force of buoyancy and equal to the W of the object. So we can write the Fv equal to W. It should be equilibrium condition, correct? Now when you can say it is stable equilibrium? Now when the Fp and W both are same and the B point is above the G point, that means the center of buoyancy is above G point, then it is called as stable equilibrium. Why we can say stable equilibrium? If you see this structure of this G point and Fp, the GB, and let it draw like this. This is the structure is there, and this is downward, correct? Now which is downward? Now this is W downward, and this is Fb upward. Okay. Now if you see this forming a couple formation is there. This is upward and this is downward. Though we have rotated in this way. Okay. Now this is G point. Now after that, what we can see again, if you remove this angular displacement, or we can say the body can be again to back to its position even after this rotation also. Okay, after rotation again we can, if you leave that rotation part, then again it will be back to its original position. Okay, so that is called the stable equilibrium condition. Okay, this is about the stable. When unstable can be called unstable equilibrium, the same condition will be there. When the body, it will be like this. For the unstable it will be slightly different. Your balloon will be like a little bit reverse side will be there. And again the top side it is going to filled by the some heavy liquid. See, it is already immersed in the fluid. As I told you, this is fluid is there, which is the balloon is going to immerse in the air. So the fluid is nothing but air. Yeah, let it be like this. Now the center again axis point of this object again will be like this. Now see, here the G point was near to the wet material or heavier material is there. Similarly here also it is going to change its position. The G point is going to at the top of this, because the maximum weight of this, the weight of the body is going to exist at which point. So that is our center of gravity. Again here the B point is going to change. So B point will be that middle point of this object, like where the force of buoyancy is going to act here. So this way. Now again let's take the same thing, let it rotate the object in slightly, and let's see what is going to happen here. Similarly, just make it a small rotation, and if after rotation if you see, yeah, it is already filled. So let it filled up to this. So bottom and the top part now it is filled. Okay, yeah. And what about this axis line? The axis line will be like this, and the G point, what about the G point here? The G point is this one. So G point means the center of gravity point, where the W is acting vertically downward, as we know. So W. And what about the B point? B point is here. Yeah, this is B and this is G, and here we know that the force of buoyancy is going to act. Correct. The force of buoyancy is going to act here. This is Fp. Now for this condition, if you slightly rotate this object in this direction, okay, it is not going to back to its original position. Okay, it is not going to back its original position. Now see, here also the couple of formations is there, but if you see, it is in the clockwise direction it is moving. That means again it is going to clearly fall like this. the balloon cannot be again to the back its position. But in this condition, if you see, it is moving in the anti-clockwise direction. Okay, it is moving in the anti-clockwise direction. If you have rotated this side, again it is going to back to its reverse side, so that it's back to its original position. But in this condition, if you see, it is rotated in this way. Again, the force of buoyancy also acting in this way. Correct, like both side clockwise direction. Okay, so this also moving in this, and this also going to move in this. Now here, if you see the movement of this force of buoyancy, this side, and this is this side, that means it is opposite to this one, anti-clockwise direction. That's why it can be back to the original one. But here, if you see the direction of this force of buoyancy and this weight of this material, how we were rotated this one clockwise direction, similarly this also is also it is supporting that one, again it is moving to the clockwise direction. That's why it will be not able to back to the original position. So for that condition, when we can say it is unstable, now when the B point, when the center of buoyancy is below the G point, then it is called a unstable equilibrium. Okay, and when the body is called as a neutral equilibrium, okay, the same balloon you can consider, and let a circle type is there. Okay, where you can see the B point and G point both are meeting at the same level, then it is called a B is equal to, or B is meeting at the same at the G point, then it is called as a neutral equilibrium. Okay, so what is the theory of this concept? I'll tell you, and one more, let me give one more example also for this. Okay, like when it can be stable, when it is unstable, and when it is neutral. Okay, let consider a small pot of this, and this is a small pot is there, and let try to play some balls on this. So a ball, let drop a ball on this at this point here. Okay, so the ball, what will happen if you leave the ball here, then it is like as per the surface it will be moved like this, again it will become to here, again it will be come back, again it will be like after some movement of this up and down here, finally the ball will be come to this position. Okay, correct. So that means the ball can be back to this position even if you take this ball up, and if you make it like there is some displacement happened here. Initially it was here, now you have you just try to move here and there. Okay, so again the ball can be back to the center point of this. Okay, in this condition we can say this is a stable equilibrium. Okay, the same pot, if you just make a reverse of it, what we did here, the same balloon we just made a reverse of that, so that the heavier materials it came to top. Now same pot, if you keep like this, okay, if you keep like this, then what is going to happen? Now the same ball, if you keep it here, okay, now the same ball, just to make it, keep it this side, little bit this side, it's going to fall, again it cannot be back with the original position to the top, because if you see both, it is that force of buoyancy and the gravity of this, it's going to pull that object to downward. Similarly, if you keep the ball even this side also, due to the gravity, it is going to fall in this way. So this is called a unstable equilibrium condition. And what about this neutral one? If I keep a normal surface, if I'll keep the ball, there will be no momentum. Where we are going to keep the ball, it will be in that position only. It is not going to change its position, okay, until unless you change its position. If I keep the object, if I take this object and it will keep it here, then it is going to be there only. Okay, because at this point the center of buoyancy and center of gravity both will be acting at the same point, so there is no changes happened, or there is no movement will be happen in this position. Okay, so this is the condition for stable equilibrium, unstable equilibrium, and neutral equilibrium. Let me remind you again, just give a recall of that. So when we can say that stable equilibrium, now when the W equal to FB, already given the condition, when the W equal to FB and the point B is above G point, okay, then it is called stable equilibrium. Correct. And unstable equilibrium when? Now when W equal to FB, see W equal to FB, both should be then only called as a equilibrium one. But the equilibrium was also again separated into three categories, as I told you: stable, unstable, and neutral. So when the equilibrium body can be called as an unstable one, now here W equal to FB, but the center of buoyancy B point is below the G point. B point is the below the G point. So a slight displacement we have done to that body in the clockwise direction. See, in the clockwise direction, and in this, that couple formation happen. This one already I shown you. This one, couple formation happen. If you see A, B and G, okay. So there is a couple formation happen, and due to that W and FB, this is FB and W, which in the clockwise direction. So you have rotated this one in the clockwise direction, and these both are also acting in the clockwise direction. So this body cannot able to back to the original position, so that it is called a unstable equilibrium. And what we have seen for the stable condition, the body can be back to the original position because it's moving in the anti-clockwise direction. Correct. So I hope you understand what is this conditions of equilibrium for a submerged body when the body is inside a fluid and how it is moving. Okay. So I hope you understand. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.